Hi there, this is your favorite non-Indian math channel, and I have a limit problem for you. So let's see how we can do it. Well, it kind of seems like Riemann sum, but it's actually not because of these powers, because of these nominators. They're changing. So if we actually try to write it like as a Riemann sum, let's see what would fail. So it would be like k. I have some. I'm not gonna write indices. Let's just see like what's going on. So I would have k over n squared plus k, and so I would usually need to take one k out, take one n out, 1 over n out. So I would say this is just limit. So I would say, okay, I'm gonna take one n out. It's gonna be 1 over n, and it would be k over n plus k over n. And here there are two problems. Both I have these n's still. So normally when I write this, so I want this thing to be like f of a plus I delta x. So this thing can be I delta x. Here it's k delta x. Let's write it like this. So it would be k delta x. Well, I have this, but I can take n as a, and I also have something else at the nominator, so this doesn't work. Okay, and but what I can do is I can just guess the solution and use squeeze theorem. So well, all of these terms are just small. They're even less than 1 over n, and we know that if they were 1 over n's, 1 over n plus 1, I explained this at the Riemann sum video. I think there I started from 1 over n. They actually end up being the same limit. This converge to ln2, and it's convergent. But if we make them n squared, they're probably gonna be 0. Okay, so we can make a guess. It's an educated guess, and let's try to show this limit is gonna be 0. So how can I do it? Of course, squeeze here. So I want to find, let's call this whole thing a. So I want to find upper and lower bounds which are gonna converge to 0. Well, here what we can do is, let's say, so I have my number a. So here I have some terms, and both nominators and denominators are changing. So for example, I can just compare this 1 over n plus 1 term with the rest of them, and let's see how would that change. For example, is 1 over n squared plus 1 bigger, or 1 over n plus 2 bigger? Well, of course, the one with the lower bounds is bigger. So 1 over n squared plus 1 is bigger than all of these 1 over stuff. So if I actually say, if I make all of these denominators 1 over n squared plus 1, and so I have 1 times of this plus 2 times of this thing is just going to get bigger. So this is my upper bound. And I can use the same logic. If I take this one for denominator, 1 over n squared plus n, this is the smallest 1 over such term, and so I have, so basically what I'm saying is this, that this term is less than 1 over n squared plus n. I'm saying this thing is 2 times 2 over n squared plus n. This thing is less than 2 over n squared plus n. It's going like this. So I have 1 plus 2 plus up to n. Okay, cool. So, well, this is just a famous sum. It's just n times n plus 1 over 2. And I have, this thing is also n times n plus 1. So this is less or equal than a. This is less or equal than, again, this is just n plus 1 over n squared plus 1. Also, well, I was guessing that the answer would be just 0, but I ended up finding something else. So here, so this should also have an 2, n times n plus 1 over 2. And here, if I look, I can just cancel these ones and these ones. This is just equal to 1 over 2 is less or equal than a. this is less or equal, then, well, I don't really need to cancel stuff here. It's just n squared plus something, okay? Here the leading term is just n. Or I can just cancel n squares and still see this n squared plus 1. Here, if I take limits, the leading terms is just here n squared, and here it's 2n squared. So this thing will also go to converge to 1 over 2. So a is between 1 over 2 and something that is converging to 1 over 2. So if I take limits of all sides, limit of a is going to be equal to 1 over 2. And this is my answer.